If you're interested in becoming a developer that writes any type of code in Python, then you need to understand these 5 very important Python concepts. These are what I see most beginner and intermediate Python programmers making a ton of mistakes with and misunderstanding when they're reading through production code. The goal of this video is to make sure that when you're reading through production Python code, you understand what's happening, you know the concept, and then you can reproduce that code and write your own pull requests and own features using Python code that other developers will understand and expect. So with that said, let's get into the video after I share with you the first very important concept you need to understand, which is the sponsor of this video. NordPass. NordPass is the ultimate password and credential management solution that I've actually been looking for a long time. Now, I don't know about you guys, but I have a lot of passwords, credit cards, bank details, private keys, etc. And oftentimes I need to share these with my coworkers, making it a constant struggle to not only keep this data secure and safe, but to allow them to access it quickly without having to message me all the time. Now, NordPass fixes this problem because it allows me to store both my personal or my business data in a single secure location and then give different access to members of my team. Now, if you don't believe me, you can check it out from the link in the description and use the code TECHWITHTIM, which means you'll no longer have to be sending messages or receiving messages asking for passwords. Not to mention that NordPass has features like autofill, data breach detection, an activity log, a password generator, and much more. Check out NordPass from the link in the description and use the code TECHWITHTIM for a 3-month free trial so you can take control over your data and your accounts. Thanks again to NordPass for sponsoring this video. So the first concept to go over here is mutable versus immutable types. Now, this is the concept that most beginner and intermediate programmers make mistakes with. Don't worry if you already understand it. There's a lot more complicated concepts, so stick around for the rest of the video. Regardless, an immutable type is something that cannot change. A mutable type is something that can change. An example of these in Python is the following. So immutable types are going to be our string, our int, our float, our boolean, our bytes type, and our tuple type. All of these are immutable, meaning once you define this, you cannot change it. However, we have mutable types in Python, which are the list, the set, and the dictionary, and pretty much any other type used from some third-party library or module. These can change, which means once you define them, you can actually modify them. Let me give you a super quick example here of immutable versus mutable, then we'll go into a more complex one using a function, which is where I see most beginners make a mistake. Okay, so let's say we have some number like x equals 1, and we say y is equal to x. And in fact, let's change this to a tuple, which remember is immutable, meaning we cannot change it. Actually, to quickly show this to you, let's try to do something like x0 is equal to 1, where we're trying to change this tuple without reassigning something to this variable. So if I go here and run my code, notice I get an error, and it says the tuple object does not support item assignment. Now, the reason it doesn't support that is because this is immutable. That means that once I define this tuple, I cannot change it. Now, if we go here and do something like y equals x, and let's come and say x is equal to 1, 2, 3, I just want to show you if I print out both x and y here, that my change to x here after assigning x to y did not affect y. The reason for that is whenever you're using immutable types, when you do an assignment to another variable, so I do something like y equals x, it makes a copy, so an actual real copy of this immutable object. Meaning that if I now go something like x is equal to 1, 2, 3, that's not going to affect y because I'm not modifying what y is storing, I'm just reassigning a new value to x. I know that seems trivial, but the reason I'm illustrating this to you is because this works differently when we change this to a list. So if I change this to a list now, and then I come and do something like x0 is equal to 100, you might think that y is not going to change, but when I run this, you see that both x and y have the same value. Now, the reason for that is when you're using mutable types and you do something like y equals x here, so you're assigning a variable to another variable, and this variable is storing a mutable type, what happens is you actually store a reference or an alias to this same object. Meaning that if I make a change to the object, like I'm doing right here, it changes for both of these variables because they're actually storing the same object. In fact, they're storing a reference to the same object. So again, if you change the underlying object, then it changes for both x and y. That's the difference between immutable and mutable types. Now let me just paste in a quick example here that will illustrate this even a little bit further. So you can see in this example, we have a function that returns the largest numbers. It returns the n largest numbers actually. What it does is it sorts the list of numbers that it accepts. So what I've done down here is I've created a list of numbers. I printed out what the value of the list was before I called the function, and then I printed out what the value was afterwards. Now take a guess if you want at what you think the output's going to be, but I'll go ahead and run the code. And you can see here that we actually get the list before that's unsorted, and then the list becomes sorted afterwards. Now, the reason this occurs is because what happens is when we call this function, we pass this nums list as the parameter numbers. Now, since we're passing a mutable object, a list is mutable, when we do a numbers.sort, what this does is actually sort the list in place. Now, numbers here is going to be storing a reference to this same list. So when I sort the numbers parameter here, since I had passed in my numbers array, it ends up sorting that numbers array that's down here. Seems a little bit strange, but the reason this is occurring is, again, because we're using a mutable object. So the point here is that you need to understand when you're using mutable versus immutable objects, because you can have functions like this that can perform side effects on your mutable objects. This is referred to as a side effect because what happens is one of the parameters is being mutated or modified inside of the function. Sometimes you want that to be the case, sometimes you don't want that to be the case. You need to be intentional when you're writing your code. So the next concept to understand here is list comprehensions. Now, the reason you need to understand this is because it's used quite a bit in Python, and oftentimes you'll see people writing fairly complicated comprehensions to simplify a line of code. Now, this can kind of do the reverse. Sometimes it can actually make it more complicated. Regardless, you need to understand what they are so that you can actually understand them if you see them in some production code. So let's have a look at a list comprehension. So the most basic comprehension you can do here is something like x, or we'll go with I for I in range, and then maybe something like 10. And in case you can't guess it here, what this is going to do is give me an array that contains the numbers 0 through 9. So let me open up my terminal and run this, and there you go, we get 0 through 9. So this is a list comprehension where essentially you write a for loop inside of a list. What you do on the left-hand side is you put the value that you want to populate the list with, and then you have some kind of iterator. In this case, we have a for loop that's going to loop through and generate these different values. Now, this is a very simple list comprehension. You can make much more complicated ones. For example, we can have a list here instead. So now if I do a list, we have a bunch of empty lists inside of this list. But just like we have a list comprehension here, we can have one inside of this list. So I can do something like for, so actually let's go with j, for j in range 5, like that. And now we have a nested list comprehension. And if I run this code, you can see that now we get a bunch of lists that contain 5 different values inside of them 10 times. Okay, so that's one thing you can do. Another thing that we can do here is the following. So let's go here and say I for I in range 10. And then we can put an if statement, and we can say if I mod 2 is equal to 0. Now this means we're going to only put this value here if this condition evaluates to true. So in this case, we're only going to put even values or 0 inside of this list. So when I run this, you see that we get all of the even values up to, but not including 10. All right, so the next concept here is the different Python argument and parameter types. Now there's quite a few, that's why I'm going through this concept, and a lot of times people have no idea what they are beyond the basic ones. So if we define a function here, like a complicated function, we can have what's known as our necessary parameters or our positional parameters that are defined in order. So I can have something like x, y. Now these are required and they are positional, meaning that if I want to pass values here, I have to do something like 1, 2, right? I pass them in the order in which I want them to be kind of assigned. So x is 1 and y is 2. However, I can actually switch things up a little bit here. And as I pass these arguments, I can do something like y is equal to 2 and x is equal to 1. And now if I go here and print this, so x and y, you see that we get 1 and 2. So this is valid when you are calling a function. You can actually write out the name of the parameter, whether or not it's positional, optional, etc., and then you can just assign it directly inside of here. This allows you to no longer pass this positionally. However, if I pass some positional arguments, so let's say I do something like 1, now I can do something like z2, y is equal to 3. So I can pass some of the arguments positionally, and then some of them I can pass using the kind of keyword argument here, or the named argument, whatever you want to refer to it as. By the way, inside of your function call, you refer to these as arguments, and up here in your function, you refer to these as parameters. So I just wanted to show you that I can pass some of these positionally. However, things get a little bit weird if I try to pass some positionally and some using the keyword. So in this case, I have like z equals 2, 1, and then y equals 3. If I try to run this, notice I get an error, and it says a positional argument follows a keyword argument, which you're not allowed to do. So if I want to use some positional arguments and the rest keyword arguments, that means that I need to start by defining my positional arguments, then I can do the keyword arguments after. Hopefully that's clear, but that was the first thing to go over. Okay, next thing is optional parameters. So inside of your function, you can mark one of your parameters as optional by putting an equal sign. So if I do z equals to, in this case, none, now this is optional, meaning I'm not required to pass it when I call this function. So if I call with 1 and 3 here, you can see this is perfectly fine. However, if I got rid of the equal sign here, so I made this no longer optional, then I get an error and it says it's missing one required positional argument. Okay, that's worth noting. Now, if I try to access z here, you'll see that actually, let's make it equal to something like 10. If I run this, it actually gets its default value. So when you make something optional, really what you're doing is providing a default value for it, which means if you don't pass that value when you call the function, by default, it will be equal to that value. Okay, so that was actually the easy stuff. Now we move on to the more complicated ones. Now we have something referred to as asterisk args. Now what this allows us to do is actually accept any number of positional arguments. So I can pass a bunch of arguments like this, okay? I can pass no additional arguments. I can pass 1, 2, whatever. It's any number after my positional arguments. So if I print out x, y, z, and then args here, and I run the code, you see that this is perfectly valid. So when I do this asterisk args, again, this means, okay, I'm going to accept any number of positional arguments at this point, so after my 2 positional arguments that I have here, and then it's going to store all of them in a tuple, which is an immutable type. Okay, if we just have star args here, then you see it works the exact same way. We accept any number of positional arguments, even 0, right? So if I have none here, this works perfectly fine. Okay, that is star args. Now we also have star quargs. So when you have star quargs, this means we're going to accept any number of keyword arguments. So let me just print out quargs here and go and pass some keyword arguments. So the keyword arguments are like this, something like x equals 1, s is equal to, I don't know, hello, b is equal to true, whatever. Let's do a capital true here. So now if I run this, you see that we have no positional arguments, but we have these 3 keyword arguments, and they are stored inside of a dictionary. So if I want to access any of these individual keyword arguments, I go quargs, and then I reference whatever the key is. So I want to reference x here, and notice I get 1. Okay, this is useful when you want to make your functions dynamic and you don't know how many regular arguments or keyword arguments you're going to be accepting. Now you can obviously pass both. So if I do something like 1, 2, 3, and then some keyword arguments here, you'll now see that we'll get both args and quargs having some values, and then we can process those values however we see fit. Okay, great. Last thing to show you is how to use these with inside of your function. So let's swap this around now, and let's say we have like a, b, and then c is equal to true, d is equal to false. Okay, now if we go here, we can actually use the asterisks to kind of break apart a list and pass different positional arguments. So let's say I have a list here, and I have 1, 2, 3 inside of it. And these are actually the corresponding values for both a, b, and not c, just a and b. If that's the case, I can't just pass this list, because if I do that, it's going to be the positional argument for a. So what I can do is put an asterisk before it, and this is actually going to kind of decompose or break this apart into 2 individual positional arguments. So if I go here and I print my a and my b, and I run this, notice I get 1, 2. Works perfectly fine, okay? Now, we have the same thing we can do with our keyword arguments. So let's say I have a dictionary that contains my keyword arguments, something like C is, I don't know, hello, and D is cool. I can actually place a dictionary here and then put 2 asterisks before it. And what this will do is break this dictionary into its keyword arguments and pass that to the function. So now I can print C and D. And when I have a look, what does it say here? C is not defined. Sorry, we need to just add a string here. Always forget that you need to do that in Python. Let's clear and rerun, and notice now that we get the values for our keyword arguments. So the next concept here is if __name equals underscore underscore main. Now, this is simply telling you if you ran the current Python file. The reason why it's important to understand that is because a lot of times you can have a bunch of different Python modules, and sometimes you run the module directly, other times it might be imported by a different module. So let's have a look at this example. In this case, we have start.py, we have some function, and then we have this if underscore underscore name equals equals underscore underscore main. We're printing run. Then we have another file here. Inside of this file, we import the add function from this start module. Now, if I didn't have this line here, what would happen is when I import this module, by default, Python would read the entire kind of block of code here, the entire file. And if I didn't have something inside of the if statement, so I just had, say, print run here, then it would actually execute that line of code, which I might not want to happen unless I'm actually inside of that module. Or sorry, not inside of that module, but if I ran that module. It's better if I just show it to you. So if I go here and I run python start.py, you see that we get run printing out to the screen. However, if I run my other file, so python otherfile.py, notice it doesn't print out run. However, if I remove this line here and we remove the indentation, now it will print run. So the purpose, again, of having this line is to determine if you ran this file directly. A lot of times you have a file where it has a ton of utility functions that are going to be imported by other files, and then you have something you might want to do when you're running it directly, like maybe initializing a game or starting some program or sending an API request, whatever it may be. But you don't want this event to occur. You don't want this code to run if it's being imported, only if it's being ran directly. So that's how you use this. That's pretty much all you need to know. Hopefully now you know. So the next concept to go over here does not involve my computer, and this is the GIL, or the Global Interpreter Lock. Now, this is exclusive to Python, and essentially what this says is that any thread that wants to be executing needs to acquire the interpreter lock. Now, what that kind of technically means for you is that you can only execute one thread at the same time, even if you have multiple CPU cores on your computer. Now, to better illustrate this, because I'm sure it's a bit confusing, on your computer, you have a CPU, or in your computer, you have a CPU. That CPU will typically have multiple cores, 2 cores, 4 cores, 8 cores, whatever it may be. Now, each one of these cores can execute one operation at a time. With hyperthreading and virtualization, you might be able to do a few more. I'm not going to talk about all the details there. For simplicity, let's say each CPU core can execute one operation. Well, this is great because that means your CPU can be working on multiple things at the same time. And if you have a complex application, it's possible that you want to be doing something like processing an image while allowing a user to type something in, while maybe sending a request to the network. There's a ton of different things you could be doing at the same time. And this is where multi-threading comes in. A thread is essentially a component of your application that's being executed by the CPU. When you start getting into larger programs, you start designing multi-threaded applications where you have different pieces of your code separated into different threads such that they can execute at the same point in time. Now, with Python, you can do this. You can have multiple threads. The issue becomes, though, that you have this global interpreter lock. Now, what that means is even if you have a bunch of CPU cores on your computer, only one of these threads can be executing at a time. That's because this thread needs to acquire something known as a lock on the interpreter. Now, I'm not going to discuss why this was implemented in Python, but what you need to know about this is that if you do actually have multiple threads, this is not going to give you a performance bonus in Python. It's not going to increase the speed at which you execute your code. So to give you a simple example here, let's say I wanted to sum the numbers from 1 to 100. Well, if I was doing this in a single thread, I'd have to sum all of the numbers from 1 to 100 in a row. However, what could be more efficient is if I split this into 4 threads, or 6 threads, or 8 threads, and I summed sections of the numbers. For example, if there was 4 of me, then I could sum the first 0 to 25, 25 to 50, 50 to 75, 75 to 100, and then I could add all of those values together, and this would allow me to sum the numbers 4 times faster. And in a traditional programming language, you can do this. You can create 4 threads. They're going to be executed on 4 different CPU cores, and this will allow you to very quickly speed up your programs using these multiple threads. In Python, you can't do that. Even though you have these multiple threads, only one of them can execute at a time, which means it doesn't matter how you split these things up. It's going to take the exact same amount of time, or approximately the exact same amount of time, to execute this code. Now I'm going to stop here. Hopefully you get the point that you can only have one thread in execution at a time. If you know that, you pretty much know the global interpreter lock. If you want to learn more, then I'll encourage you to read about it, or let me know in the comments if you want to see me make an entire video on it. Regardless, I'm going to wrap it up here. I hope that you found this helpful, and I look forward to seeing you in another YouTube video.